The model you chose because it was 78% cheaper, it's actually costing you 22% more. That's not a hypothetical. It's from a peer-reviewed paper, and the real numbers are even worse.
It usually starts late at night. A developer checks their inbox, opens a routine cloud hosting update, and finds a bill that defies basic math. Developers' logs on Hacker News document the scale of the damage. One user reported a $638 bill in 6 weeks while using the Cursor code editor. Another developer pointed their API key at a billing-enabled project and triggered a $127 charge from Google's Gemini in exactly 7 days, despite virtually zero active usage. In almost every instance, these developers had intentionally selected a budget AI model. They audited the pricing pages and picked the cheapest available option to keep their operational costs low.
A team from Stanford, Berkeley, CMU, and Microsoft Research just published what might be the most important paper for anyone running AI workloads this year. They tested 8 frontier reasoning models across 9 benchmarks, over 11,000 queries total, and discovered that per token pricing, the number every developer uses to compare costs, is fundamentally misleading. In the worst case, it's off by a factor of 28x. They call it the price reversal phenomenon. The model with the lower listed price frequently ends up costing more. Not occasionally, 21.8% of all model pair comparisons showed the cheaper model actually costing more.
Let's look at the actual data. Claude Opus 4.6, the model with the second highest listed price at $30 per million tokens, was the second cheapest in actual execution. Meanwhile, Gemini 3 Flash, listed third cheapest at $350 per million tokens, was the most expensive in practice. On MMLU Pro specifically, Flash cost 6.2x more than GPT 5.2. The worst reversal? Gemini 3 Flash is listed at 1.7x cheaper than Claude Haiku, but its actual cost on MMLU Pro was 28x higher. That's not a rounding error, that's an order of magnitude miscalculation.
Hello, community. So great that you're back. Sometimes I wonder, if I pay for a tiny, not so expensive reasoning language model, and I have a complex task and it does a lot of reasoning, you see this here in blue, and it comes to a finish, and I have to pay a price. And then I think, you know what? Now I try a real premium reasoning language model, really expensive. But with advanced reasoning methodology, will it just be a laser beam that just goes absolutely precise to the finish without any deviation? Which model do I have to
So
pay?
why does this happen? The answer is invisible to most developers. Thinking tokens. When you send a query to a reasoning model, the response you see is just the tip of the iceberg. Behind the scenes, the model generates a massive chain of internal reasoning steps, thinking tokens, that you never see but absolutely pay for. Across the 8 models tested, thinking tokens account for over 80% of total output cost. Here is the kicker. Removing thinking token costs from the analysis reduces ranking reversals by 70% and raises the correlation between listed price and actual cost from 0.563 to 0.873. Listed pricing is a decent predictor of cost only if you ignore the biggest cost component.
Here's the example that makes this visceral. On an AME 2025 competition math problem, 2 models reached the exact same correct answer via radically different paths. GPT 5.2 used 562 thinking tokens. Gemini 3 Flash used over 11,000 thinking tokens. Same problem, same correct answer. A 20x gap in thinking tokens. At listed rates, that single query cost 4.3x more on Flash, the supposedly cheap model. Zoom out to all 9 benchmarks. Claude Opus consumed 24.2 million total thinking tokens. Gemini 3 Flash consumed 208 million, an 860% gap. The budget option is the premium one in disguise.
Page is no longer translating to the final invoice. This chart compares listed API prices. On the left, Google's Gemini 3 Flash sits at $3.50 per million tokens. On the right, Anthropic's Claude Opus demands $30 for that same volume. On paper, Claude is 9 times more expensive. But a March 2026 peer-reviewed paper from researchers at Stanford, UC Berkeley, Carnegie Mellon, and Microsoft Research tested that assumption. They ran 11,872 queries across 8 different models and 9 distinct benchmarks to see what happens when the code actually runs. They identified a price reversal phenomenon.
The Stanford paper quantifies what developers have been learning the hard way. On Hacker News, developer Enthipes shared their story, a $638 cursor bill in just 6 weeks. They had not changed their usage pattern. The reasoning model behind the scenes had simply started generating more thinking tokens per query as the underlying model was updated. Another developer, PPC Vote, discovered $127 in charges after just 7 days on Gemini. Their lesson? I should have set up billing alerts from day one. But billing alerts do not help when you do not know the real cost driver. One developer reported that a simple 2-word response consumed over 600 input tokens, a 300x overhead. Another found 2,847 tokens billed for what should have been a 45-token prompt. Here is the finding the paper buries that might be the most important one. The cost analysis was completely decoupled from accuracy. But when you combine cost and performance data, a new metric emerges: cost per correct answer, and it inverts the pricing page entirely. On the GPQA benchmark, Kimi K.5 produces the cheapest correct answers at 87 cents each. Claude Opus, listed at $30 per million tokens, costs just $1.40 per correct answer. Meanwhile, Gemini Flash, the budget option, costs $5.61 per correct answer. The cheap model produces the most expensive correct answers. If you extrapolate to a full evaluation suite, Claude costs about $9.30 for reliable answers. Grok 4, despite reasonable per-token pricing, costs $95. That is 10x the price for equivalent quality. Everything we just covered assumes single-turn queries. In production, most workloads involve conversations, and multi-turn interactions make the hidden cost problem exponentially worse. Here is why. Each turn in a conversation resends the entire context. A model that generates excessive thinking tokens, in turn 1 creates a larger context for turn 2, which generates even more thinking tokens, which creates an even larger context for turn 3. By turn 8 in a typical conversation, a budget model that started 78% cheaper is now costing 10.5x more than the premium alternative. That is not a theoretical projection. It is what happens when you compound the thinking token overhead across realistic conversation lengths.
Accuracy is cheaper than a budget model that requires retries. Every wrong answer from a cheap model adds the cost of the initial failure, the automated retry, and the human verification needed to fix the error. Efficiency determines the final invoice. Because premium models reason with precision, they consume a fraction of the compute, making them the more economical choice in a production environment. To protect your budget, you have to stop estimating costs based on listed prices. Run at least 100 sample queries from your actual workload to find your real operation.
So, what do you actually do about this? First, the ecosystem is already responding. Cost Router, launched this month, routes queries to the cheapest model that can actually answer correctly, not the cheapest per-token model. Chameleon provides real-time cost decomposition, showing exactly where your money goes. And European Swallow AI has built thinking token budgets directly into their inference API. Second, here are 5 things you can do right now. Stop using listed API prices for budgeting. Benchmark your actual workloads. Set thinking token budgets where available. Anthropic budget tokens parameter is a game changer. Implement cost per correct answer tracking, not cost per token. Run A/B tests on premium versus budget models with your actual queries. And set billing alerts at 50% of expected spend, not 90%. The age of picking the cheapest model from a pricing page is over. The real metric is cost per correct answer, and premium models win. That's the deep dive for today. If this changed how you think about AI, hit subscribe. We go deep every week, not just headlines. Full article with all the sources is on ComputeLeap.com. See you in the next one.